Alright, so we're going to continue into Chapter 4 now, looking at Section 4.1. And our last four sections of this course are going to be Sections 4.1, 4.2, 4.3, and then 5.1. So it is actually Chapters 4 and 5, so be aware of that. You will take your last test on Chapter 3, and then these sections will be on your final exam. So still have a lot of stuff to do, a lot of stuff to cover, but your test that covers this stuff will be your final exam. So just be aware of that as you're watching each of these videos. So we are going to get into dealing with functions and some different things with functions than what we've talked about so far. Specifically, we're going to talk about inverse functions and one-to-one functions. And so a function is considered to be one-to-one if for the elements of A and B in the domain of function f. So that means you take a number, you take a letter A or a number for A and a number for B. If they're not equal, this being a key thing here, they're not equal, then that implies that f of A, so when you put A in, and then when you put B in, f of B, those two values should also not be equal. Now, that may not mean a whole lot to you, but essentially what it means is that if you can put a number in for x, two different numbers that are obviously different, then you should not have a y value repeat. If you remember when we talked about functions back in, I guess, Chapter 3, we talked about how a function is going to be a relation where the x value doesn't repeat. Well, now a one-to-one function is a function, so the x value still doesn't repeat, but then also the y value doesn't repeat. And so if you are looking at that and you say, well, I could get the same y value from different x's, then it's not a one-to-one function. Okay, so we're going to look at some examples and make sure that makes sense to you. And so you can see that note in the middle of the screen. It says that is different values of the domain correspond with different values in the range. Again, if I put a number in for x, it gives me a distinct number for y. If I choose a different number for x, I get a different number for y. Okay? And so what we want to start out doing is determining if a function is one-to-one. And so we want to be able to take sum A not equal to sum B, put those numbers in, and make sure that f of A is not going to be equal to f of B. That's what we're trying to show. Okay? So, if we were to take this function of negative 4x plus 12, and we put in A and B. Okay, we're just going to put in the letters A and B. And so we're going to say that negative 4a plus 12 is not going to be equal to negative 4b plus 12. Now, in doing this, when you set this equation up, we're hopefully going to get to the end and see that because A and B were different numbers, what we get from that is also going to be different numbers. Okay, so let's simplify. In this case, you could subtract 12, and the 12s are going to cancel, and you're going to get negative 4a is hopefully not going to be equal to negative 4b. And if you divide by negative 4, those divide out, and so you get a is not going to be equal to b. And so because we put in A and B and they were different numbers, okay, when we found f of A and we found f of B, that's this answer down here at the bottom. When we find that, we find out they're not the same value because we started out by saying that A and B are not the same number, okay? And so what this tells us is that no matter what number we put in for A and what number we put in for B, as long as those are different numbers, we're getting different numbers at the end. And so this function is one-to-one. Now, I know that is somewhat confusing, and I know that maybe is hard to understand, but let me show you one that is not one-to-one. I think this will make a little more sense for you. So, for this example, again, we want to show that this function is either one-to-one or that it's not one-to-one. So if we can show that a y value repeats, then we know that this is not a one-to-one function. So let's do this. Let's find f of, let's do f of 3. And then let's also find f of negative 3. So those are two different numbers, right? We're going to put those numbers in and see what we get. Well, when we put in the 3, we have 3 squared. And as we simplify this, we have 49, 9, not 40, 49. Minus 9, which is going to be the square root of 40. Now, we don't know the square root of 40 off the top of our heads, and that's fine. We don't have to. If putting in negative 3 gives us a different answer, then we would say, well, this is one-to-one. But if it gives us the same answer, we've got a problem. So let's put it in and let's see. So here again, we have 49 minus now negative 3 squared. And as you simplify that, we have 49 minus 9, because again, negative 3 squared is positive 9. And so we find out that this is the square root of 40. Now, we have a problem, because if it's one-to-one, it says that if we put in an a and a b that are not the same number, if it's one-to-one, then f of a is not going to be equal to f of b. Well, we put in two different numbers, right? 3 and negative 3 were two different numbers. But when we simplify that, we ended up with square root of 40 and square root of 40. We got the same y value, the same f of a or f of b value. And so because of that, this is not one-to-one. Now, as you work through your math lab, you'll practice that a little bit. We just want to show that this one is not one-to-one. If it's one-to-one, you're going to be able to take it any a and any b and put it in and show that it's going to give you a unique number. If it's not one-to-one, you're going to be able to show an example and say, oh, well, if I put this number in, I put this number in, even though they're different, I'm going to get the same answer. Okay, so oftentimes what will happen is if you have an exponent of 2, it's usually not going to be one-to-one, because we know a parabola shape has two y values that would be the same, right? Maybe a positive 5 for the y value, and then for two different points. And so you could have maybe 2, 5 and 2, negative 5 maybe as an ordered pair. And so that y value repeating means that it is not one-to-one. Now, if we continue on, the reason, or one easy way that we can tell if a function is one-to-one is by what we call the horizontal line test. Again, when we talked about functions previously, we've talked about the vertical line test and how you can draw a vertical line through any point, and if it only touches it once, then it's a function. Well, now the horizontal line test allows us to know if it is a one-to-one function, because if you draw a horizontal line and touch 2 points at the same time, then a y value got repeated, and that y value being repeated means it is not one-to-one. Okay, and so that's what this is referring to. And so let's try that. If you look at this first graph, if you were to draw horizontal lines through any point on this graph, you're going to see that you would only touch 1 point at a time. Now, even here around the origin, it never goes completely horizontal. Okay, it's always slowly going up. And so this function is 1-to-1. Again, we're looking to see, does a y value repeat? In this case, it doesn't. However, if you look at this quadratic function, this parabola on the other side, if you draw a horizontal line, when you're touching 2 points at the same time, they have the same y value. And so because of that, this one is not 1-to-1. Okay? And so we're going to use 1-to-1 functions when we talk about inverse functions more later on. But this is something you've got to understand before you can really get into inverses. You've got to understand what is a 1-to-1 function. And so that's how we're going to tell. We're going to look to see, is there a y value that would repeat? If there is, we can show that if we know the equations. If we don't know that, and we know the graph, then we obviously could see that it is either 1-to-1 or not 1-to-1 based on that horizontal line test. If you have any questions about that, let me know. We're going to follow this up in the next video.